guys, today we're going to solve one JEE Advanced Inverse Trigonometry Summation problem. And this question was asked in JEE Advanced 2013. The question is cot of summation of cot inverse of 1 plus summation of 2k from k is equal to 1 to the n number of elements. And for this big sigma notation, it is from n is equal to 1 to 23. This is the question we have. And guys, this sigma notation is for this whole expression. That means cot inverse of 1 plus summation of 2k from k is equal to 1 to the n number of elements. This sigma notation is for this whole expression. So, how I'm going to solve this question is, first I'm going to expand this summation. I'm going to expand this summation and I'm going to find the value of this. How will I expand this summation? First I will put 1 in place of k. Next I will put 2 in place of k. Next I will put 3 in place of k. All the way up to n. All the way up to n, and I will add each and every element, and that's how we solve the sigma notation. Correct now? I will put 1 in place of k, 2 in place of k, 3 in place of k, all the way up to n, and I will add each and every element, and that's the method how we expand the sigma notation. When I do like that, we will get the summation as summation of 2k from k is equal to 1 to the n number of elements as, when you put 1 in place of k, you will get it as 2. When you put 2 in place of k, you will get it as 4. When you put 3 in place of k, you will get it as 6, and all the way up to 2n number of elements. Correct now? When I put 2 in place of k, you will get 2. When you put 1 in place of k, you will get 2. When you put 2 in place of k, you will get 4. When you put 3 in place of k, you will get 6, and it's going on all the way up to 2n. Now, in this series, I'm going to take 2 common. When I take 2 common, I will get the series as 1 plus 2 plus 3 all the way up to n. In this series, I just took 2 common. When I take 2 common, I will get this expression as 1 plus 2 plus 3 all the way up to n. Because guys, when I take 2 common in 2, I will get 1. When I take 2 common in 4, you will get 2. When I take 2 common in 2n, I will get n. And that's what I did now. Now, what is this 1 plus 2 plus 3 all the way up to n? 1 plus 2 plus 3 all the way up to n is nothing but sum of first and natural numbers. Sum of first and natural numbers is nothing but n into n plus 1 divided by 2. Correct now? You know that already. Sum of first and natural numbers is n into n plus 1 divided by 2. That's a basic concept that you guys study in your sequence and series, even in your lower grades. Okay, so sum of first and natural numbers is nothing but n into n plus 1 divided by 2. So 1 plus 2 plus 3 all the way up to n is sum of first and natural numbers. That is nothing but n into n plus 1 by 2. Now this 2 will get cancelled, and finally we get this value of summation as n into n plus 1. Now we have found the value. We have found the value of this small summation, that is n into n plus 1, by expanding it and using our sequence and series techniques. Okay, using our sequence and series techniques, I have found the value of this summation, and that is nothing but n into n plus 1. Now I will put this value in this summation. That's what I am going to do now. I will put this value in this summation. When I put this value, what you will get is, you will get the same expression as cot of summation of n is equal to 1 to 23 of cot inverse of 1 plus, what is summation of 2k from k is equal to 1 to the n number of elements? That is n into n plus 1. Just now we expanded and found the value of this particular small sigma notation. Okay, so the value of this summation is n into n plus 1. Just I replace the value as n into n plus 1. This is what you will get when you replace this summation by n into n plus 1. Now, the next step that I am going to do is, it's an obvious step, because every time when you see an inverse trigonometry summation problem, that is nothing but ITF, inverse trigonometry function summation problem, you need to convert the cot inverse in terms of tan inverse. That's a very important step. Whenever you see an inverse trigonometry summation problem, the first thing that you need to strike in your mind is, you need to convert the given ratio in terms of tan inverse. So when I convert this cot inverse in terms of tan inverse, what you will get is cot into summation only, summation of n is equal to 1 to 23. When I convert this cot inverse in terms of tan inverse, I will get this ratio as tan inverse of 1 by 1 plus n into n plus 1. This is what I will get. This is what I will get when I convert this cot inverse in terms of tan inverse. Because guys, we know that your tan theta and cot theta reciprocal relation. So your tan theta, your cot theta is equal to 1 by tan theta. So the reciprocal of this inside expression will be nothing but 1 by 1 plus n into n plus 1. That's what I did now. Now, this is the place where the manipulation starts. Guys, a very important one. This is the place where your manipulation starts. That means what you should add in the numerator, what you should do in the denominator, what you should multiply, what you should divide. Those things, now only it starts. And that is called as manipulation. Very important part. So what I'm going to do is, in the numerator, we are having 1, right? Correct now? In the numerator, we are having 1. Can't I write this 1 as n plus 1 minus of n? Can't I write like that? Can't I write the 1 in the numerator as n plus 1 minus of n? Anyway will be getting 1 because this n minus n will get cancelled and you will be left out with 1 in the numerator. That's what you will get. But what's the reason behind doing such things? You may ask, I just mugged up whatever solution is given and I just wrote the numerator as n plus 1 minus of n. But I did not mugged up. I will say what's the reason. That is use the tans of A minus tans of B formula. We know now guys. I will write here. Tans of A and tans of B is equal to tans of A minus B divided by 1 plus AB. Correct now? So in order to use this particular formula only, I'm writing 1 as n plus 1 minus of n. Because this particular expression looks like a form of tan inverse of A minus B divided by 1 plus AB. Correct now? Where your A is n plus 1 and B is n. So as this looks like a form of tans of A minus B divided by 1 plus AB, I can write the same expression as cot into summation from n is equal to 1 to 23 of tan inverse of n plus 1 minus of tan inverse of n. Just by using this particular formula. Tans of A minus tans of B is equal to tans of A minus B divided by 1 plus AB. You may ask, how do I know that I should write this 1 as n plus 1 minus of n? It's very simple guys. Already we know that we are going to use tans of A minus tans of B formula. That is nothing but tans of A minus B divided by 1 plus AB. That shows that this particular inside value should looks like a form of A minus B divided by 1 plus AB. That means your denominator should be 1 plus AB. If your denominator should be 1 plus AB, your A should be n plus 1 and B should be n. Then of course, your numerator should be A minus B, that is n plus 1 minus of n. It's not a very big deal guys. It's not a very big deal like getting into KGF and being like our Rocky boy. Okay? It's not a big deal like that. So that's what I did now. Just I use this formula and I convert it into this form. Now it's a very easy step. Try to open this summation. How will I open this summation? Is first put 1 in place of n. Next put 2 in place of n. Next put 3 in place of n. All the way up to 23. When you do like that, you will get many terms. Out of those terms, most of the terms will get cancelled and you will be left out with 2 terms. What are those terms is tan inverse of 24 minus of tan inverse of 1. You will be left out with these 2 terms. When you expand this particular sigma notation, that is n is equal to 1 to 23, you will put 1 in place of n, next put 2 in place of n, next put 3 in place of n, all the way up to 23. When you expand like that, you will get many terms. You will get many terms, and out of that, most of the terms will get cancelled, and you will be left out with 2 terms, that is tans of 24 minus tans of 1. Now, it's very simple. It looks like a form of tans of A minus tans of B. What is tans of A minus tans of B? Same formula. Tans of A minus B to 1 plus AB. So when I write like that, I will get this expression as tans of A minus tans of B is tan inverse of A minus B. What is A minus B? 24 minus 1, that is 23. Divided by 1 plus AB. What is 1 plus AB? 1 plus 24 into 1. So 1 plus 24 is 25. So this is 23 by 25 is nothing but A minus B divided by 1 plus AB. Now, I just use this formula tans of A and tans of B. That is your tans of A minus B divided by 1 plus AB. After this, try to convert this tan inverse in terms of cot inverse so that you can cancel this cot and cot inverse. Okay? You need to convert this tan inverse in terms of cot inverse so that you can cancel this cot and cot inverse. When you convert this tan inverse in terms of cot inverse, what you will get is cot inverse of 25 by 23. Cot inverse of 25 by 23. Then this cot inverse will cancel, and the final answer is 25 by 23. So very good question, guys. Just like converted your tan inverse in terms of cot inverse so that this cot and this cot inverse will get cancelled. So the inside value will be final answer. So 25 by 23 is the final answer for this question. The very important part is this formula. So tans of A minus tans of B is tans of A minus B divided by 1 plus AB. So that's all, guys. I hope you guys would have enjoyed this question. And it's a beautiful question. So thank you. Make education simple.